Okay, so now I'm going to talk about how the textbook is organized. So, if you took Physics 161 at MCC and you used the Spiral Physics textbook for Physics 161, there were 4 different models in the textbook. For Model 1, we looked at one-dimensional motion. For Model 2, we looked at two-dimensional motion, but all the forces and accelerations were constant. In Model 3, the acceleration didn't have to be constant. The force didn't have to be constant, so we can say non-constant acceleration. And this was in 3 dimensions. And that's what we're going to start off looking at in dynamics. So in Chapter 12, we're looking at point particles moving in 3 dimensions, and the acceleration does not have to be constant. In the Spiral Physics textbook in Model 3, our point particles were not moving really, really fast, which means we didn't have to use relativity, and they weren't really, really small, which means we didn't have to use quantum mechanics. So these are classical objects, so not really small, not really, really fast. Okay, and then in Physics 161, for Model 3, we looked at kinematics, which is looking at position, velocity, acceleration, time. And then after that, we looked at dynamics, also for point particles in 3 dimensions with non-constant acceleration that weren't going really, really fast and that weren't really, really small. For dynamics, that was when we did Newton's second law. The sum of the forces is equal to mass times acceleration. But we're not going to call that dynamics in our textbook because the whole textbook is dynamics, so that would kind of be a problem. Okay, so instead of in Physics 161, what we called the dynamics section, now that's going to be called kinetics of a particle. That's force and acceleration, just like we had in Spiral Physics. So this is now called kinetics, which is kind of nice because now we have kinematics and kinetics. Okay, so what was Model 3 in Spiral Physics, kinematics, is now what we're going to be looking at in Chapter 12. What was Model 3 dynamics in Physics 161 is now Chapter 13. Okay, and let me pause here to say what we're learning in dynamics might be everything that you wanted to learn in Physics 161, but we didn't because we didn't go into that much detail. Okay, so we are going to be going into a whole lot more detail than we did in Physics 161. Okay, and then next we have conservation laws. Our conservation laws in Physics 161 were work is equal to the change in kinetic energy. There are different ways of writing that equation, but that's maybe what we started off with. And then the impulse, I think I'm just going to write impulse, is equal to the change in momentum. One problem we do have in this course is that the letters which we liked to use in Physics 161, we're not always using the same letters in the dynamics course. Okay, this may make it a little hard when you look at the equations that we have listed here. So here's how they write the principle of work-energy. Well, this is how I wrote the work-energy relationship. Now, these equations are really saying the same thing, but I used a W for work here, and they're using a U for work. And then they have T1 and T2. If you bring the T1 over to the other side, that'd be T2 minus T1. That's the change in kinetic energy. So they're using a T for kinetic energy. And then here I just called it the work, but they're saying the sum of all the work, which is what this really is. If you remember back in Physics 161, we had different equations for work and energy. Sometimes we use the total work, sometimes we use the work done by non-conservative forces. I'm just going to kind of brush over that now and basically just want to point out that these equations are the same, but the letters that we're using in dynamics are sometimes different than the letters that we use in Physics 161, and it's kind of even worse than that because here we're using a U for work, here we are using a W for work, and then when we include potential energy, we're going to be using a V for potential energy. But when we did Physics 261, we used a U for potential energy and V was just potential. So the letters are going to be kind of a mess, but thankfully we don't have to worry about that until chapter 14. Okay, so in chapter 14, we're looking at work energy. In chapter 15, we're looking at impulse momentum. So work energy is going to be chapter 14, impulse momentum is chapter 15. Okay, and then, just like we did in spiral physics, we get to spiral through these 3 or 4 topics again, but now with objects that have size and shape, which we're going to talk about rigid bodies when we get to this part of the textbook. Okay, so instead of a point particle, now the object is a rigid body. It has size and it has shape, so we're not treating it as a point anymore. The objects still have to be not really, really small and not moving really, really fast. The acceleration can still be non-constant, and we're still going to look in 3 dimensions, but maybe mostly in 2 dimensions, because I think chapter 20 and chapter 21 chapter 20 and chapter 21 are more on 3-dimensional motion, which we're not going to cover in this course, so we're only going up to chapter 19. But you're welcome to read through chapter 20 and chapter 21 on your own, and also chapter 22, we're not going to get to. Okay, so for chapter 16, we're back with kinematics. So kinematics with rigid bodies. That's going to be chapter 16. And then kinetics for the rigid body, that's chapter 17. So same types of problems that we did in Physics 161, Model 4, dynamics with spiral physics, but more detail in the dynamics course. Okay, and then we have our conservation laws. So chapter 18 is rigid bodies, work, and energy. So this is chapter 18. And chapter 19, impulse momentum for rigid bodies. Notice that there's 4 sections here, there's 5 sections here, and we started off with 10 sections in chapter 12. So we are going to be spending less time on the final 2 chapters. If there's an asterisk next to the section here, it means that the section may be skipped when we go through the course. We are going to be skipping some sections. Some of them are not marked, and we're skipping them anyways. Okay, so this is the basic overview of the course. And before we move on and get started on the course material, there's a few things that I want to point out. There's another YouTube channel that you might be interested in checking out. This is Jeff Hansen's YouTube channel. If you go to my channel, you should find a link to his channel there. So he goes through the same material. Last year he had only had videos posted mostly for the first half of the course, so I don't know in the meantime if he's uploaded any videos for the second half of the course. But I recommend checking out his videos if you feel like you need more help with dynamics. Also, when you are watching videos that I post on example problems, maybe not for the first videos in a section, but when you feel like you're kind of getting a hang of things, I recommend pausing the video as I'm going through and trying to work out the problem on your own, and then going back to watch the video to check your work. You can change the speed that the video plays at on YouTube, so if you feel like you have a good grasp of what's going on, you might want to play the video at a faster speed. If you're trying to do the problem on your own, and you feel like you really understand it, you might just want to watch the video fast and check your solution at the end. Alright, so that concludes this video, and now we're going to get started on Chapter 12.